When mysterious objects like 3I Atlas streak through our solar system, how do scientists determine if they're natural space rocks or, something far more extraordinary? The process of distinguishing between cosmic debris and potential alien technology involves rigorous scientific methods, advanced telescopes, and careful analysis of physical properties. From spectral signatures to orbital mechanics, astronomers have developed sophisticated techniques to separate fact from fiction in the search for extraterrestrial intelligence. A rare visitor from deep space. What makes an object suspicious enough to warrant investigation for potential alien origins? When astronomers discovered 3I Atlas in July 2025, they immediately began analyzing its characteristics using established protocols for identifying unusual celestial visitors. The object's extreme velocity of 58 kilometers per second and hyperbolic trajectory initially raised questions about its nature, similar to how Oumuamua sparked scientific debate in 2017. Scientists look for specific markers that distinguish natural objects from potential artificial constructs, including surface composition, structural integrity, and behavioral patterns. Natural interstellar objects typically display predictable properties based on their formation in distant stellar systems, while hypothetical alien technology might exhibit anomalous characteristics that defy conventional physics. The key lies in systematic observation and measurement rather than speculation. Professional astronomers use multiple independent observation methods to verify their findings and eliminate human error or equipment malfunction. Every mysterious space object receives the same rigorous scientific scrutiny, ensuring that extraordinary claims require extraordinary evidence. This methodical approach has successfully identified thousands of natural objects while maintaining vigilance for genuinely anomalous discoveries. The scientific community remains open to finding evidence of alien technology while maintaining strict standards for verification and peer review. The breaking discovery. How do scientists separate genuine discoveries from false alarms when studying mysterious space objects? The confirmation process begins immediately after initial detection, involving multiple independent observations from different telescopes worldwide. When Atlas telescopes first spotted 3I Atlas, teams at observatories across Chile, Hawaii, and South Africa began collecting data to verify its properties and trajectory. Scientists analyze orbital mechanics first, determining whether an object follows natural gravitational physics or exhibits unexplained acceleration patterns that might suggest propulsion systems. Spectroscopic analysis reveals surface composition, helping distinguish between rocky, icy, or metallic materials that provide clues about natural versus artificial origins. The object's rotation rate, brightness variations, and thermal emissions undergo careful scrutiny to identify any anomalies inconsistent with natural formation processes. Professional astronomers coordinate through international networks, sharing data and cross-referencing observations to eliminate observational errors or equipment malfunctions. The International Astronomical Union maintains strict protocols for announcing discoveries, requiring multiple confirmations before official designation. Scientists also consider alternative explanations for unusual properties, exploring whether natural phenomena could account for seemingly anomalous characteristics. This systematic approach ensures that only genuinely unexplained objects receive serious consideration as potential evidence of alien technology, while protecting the scientific community from premature or inaccurate conclusions that could damage public trust in astronomical research. The discovery story. What specific techniques do astronomers use to analyze potentially artificial objects in space? The investigation process relies heavily on photometry, spectroscopy, and astrometry to build comprehensive profiles of mysterious visitors. David Jewett and Jane Liu, pioneers in studying distant solar system objects, established many protocols now used for interstellar object analysis. Scientists measure brightness variations over time, looking for rotation patterns that might indicate artificial symmetries or unusual structural properties inconsistent with natural formation. Spectral analysis reveals elemental composition by examining how objects absorb and reflect different wavelengths of light, providing chemical fingerprints that distinguish manufactured materials from natural rock, ice, or metal. Thermal imaging detects heat signatures that might indicate internal power sources, active machinery, or artificial temperature regulation systems. Radio telescopes scan for electromagnetic emissions that could signal communication systems, navigation equipment, or other technological signatures. High-resolution imaging attempts to resolve surface features, searching for geometric patterns, artificial structures, or manufacturing marks that would distinguish technology from natural geological processes. Scientists also monitor for trajectory changes that might indicate course corrections, propulsion systems, or intelligent navigation, rather than purely gravitational motion. The Very Large Array and other radio telescope networks continuously monitor for signals from objects of interest. Modern computational power allows rapid analysis of vast datasets, enabling scientists to process observations from multiple wavelengths simultaneously and identify subtle anomalies that might escape individual telescope observations. A stranger in our midst. So, how do natural objects behave differently from potential alien artifacts when observed through powerful telescopes? Well, natural interstellar objects typically show predictable characteristics, based on their formation environments and the effects of cosmic ray exposure during their really long journeys through space. Asteroid composition usually follows known patterns, rocky, metallic, or icy materials that are consistent with planetary formation processes around distant stars. Scientists expect natural objects to display signs of space weathering, like surface darkening from cosmic ray bombardment and micrometeorite impacts that build up over millions of years. Their rotation rates generally fall within ranges determined by gravitational interactions during ejection from their parent star systems, and these are typically measured in hours, not artificially precise periods. When it comes to comets, natural outgassing produces predictable chemical signatures as volatile materials sublimate while approaching the sun, creating those characteristic coma and tail formations. The structural integrity of these objects follows physical laws, how different materials respond to gravitational stresses, temperature swings, and rotational forces during interstellar travel. Scientists use computer models to predict how various natural materials would appear after extended exposure to cosmic radiation and extreme temperatures in interstellar space. On the other hand, artificial objects might show unusual geometric shapes, precise rotational periods, unexpected material compositions, or surface features that just don't line up with natural formation processes. The Spitzer Space Telescope and other infrared instruments can detect thermal anomalies, which might hint at internal power sources or artificial heating systems. And with advanced imaging techniques, researchers examine surface textures, searching for manufacturing marks, geometric patterns, or structural elements that would suggest intelligent design rather than natural geological or impact processes. The predecessors. What lessons did scientists learn from previous mysterious objects that shaped current investigation protocols? The 2017 discovery of Oumuamua really changed the game for astronomers, establishing comprehensive analysis frameworks that are still in use today. Robert Warwick at the University of Hawaii was the first to detect Oumuamua, which showed unusual acceleration patterns that initially puzzled scientists, until natural explanations involving outgassing were confirmed. The controversy over Oumuamua's elongated shape and slight acceleration taught researchers the importance of gathering multiple types of observational data before jumping to conclusions. Avi Loeb from Harvard University suggested considering artificial origins for Oumuamua, which sparked important discussions about scientific methodology and the burden of proof needed for extraordinary claims. Then there was 2I/Borisov, discovered in 2019 by amateur astronomer Gennady Borisov, which provided a more conventional example of an interstellar comet with clearly natural characteristics. These experiences established standard protocols for studying interstellar objects, like immediate spectroscopic analysis, trajectory monitoring, and international coordination for follow-up observations. Scientists learned to consider both natural and artificial explanations at the same time, while maintaining rigorous standards for evaluating evidence. The experiences with these objects also highlighted the need for rapid response capabilities, since interstellar visitors are only observable for limited time periods before they leave the solar system. Nowadays, modern protocols include automated alert systems that notify astronomers worldwide within just a few hours of discovery, enabling coordinated international observation campaigns to maximize data collection from these rare cosmic visitors. The cosmic journey. How do orbital mechanics help scientists distinguish between natural objects and potential alien spacecraft? Well, natural interstellar objects follow predictable trajectories determined by gravitational interactions with the sun and planets. while artificial objects might show unexplained course corrections or propulsion signatures. Gravitational physics gives us precise mathematical frameworks for calculating expected paths, allowing scientists to spot any deviations that could indicate active navigation systems. For example, the trajectory of 3I/Atlas follows a hyperbolic orbit with an eccentricity of 6.14, which is totally consistent with natural ejection from a distant star system millions of years ago. Scientists use sophisticated computer simulations to trace backward trajectories, trying to identify possible origin star systems and validate natural formation scenarios. Of course, unexpected acceleration or deceleration patterns might indicate propulsion systems, though natural phenomena like outgassing can also cause trajectory changes in comets and asteroids. JPL's navigation teams keep a close watch on object trajectories using radar and optical observations, measuring positions with extraordinary precision to catch even the subtlest motion anomalies. Artificial objects could show perfect geometric flight paths, precise timing in trajectory changes, or acceleration patterns that just don't fit with known natural forces like solar radiation pressure or gravitational slingshot effects. The Deep Space Network offers radar tracking capabilities that can pick up tiny changes in velocity or trajectory that optical telescopes might miss. Scientists also analyze how objects respond to solar radiation pressure, gravitational perturbations from planets, and other natural forces, just to make sure their motion follows purely physical laws, or to see if it hints at intelligent control systems managing their flight paths through the solar system. A scientific goldmine. What advanced technologies enable scientists to determine if mysterious objects are natural or artificial? Well, modern astronomical instruments provide, honestly, unprecedented capabilities for analyzing the physical properties and behavior of potential alien artifacts versus natural space debris. Spectroscopic analysis, using instruments like those on the James Webb Space Telescope, can identify specific chemical compositions, revealing whether objects contain materials consistent with natural formation or, unusual artificial alloys. High-resolution imaging from ground-based adaptive optic systems and space telescopes can resolve surface features as small as tens of meters, searching for geometric patterns, manufacturing marks, or structural elements that would indicate intelligent design. Radio astronomy facilities like the Very Large Array continuously monitor for electromagnetic emissions that might indicate communication systems, navigation equipment, or other technological signatures from mysterious objects. Infrared observations detect thermal signatures that could reveal internal power sources, artificial heating systems, or temperature regulation inconsistent with passive solar heating of natural materials. Advanced computer modeling allows scientists to simulate how various materials and structures would behave under different conditions, comparing observations with theoretical predictions for natural versus artificial objects. Gravitational wave detectors provide additional monitoring capabilities for massive objects that might employ, say, exotic propulsion systems. Machine learning algorithms process vast amounts of observational data, identifying subtle patterns and anomalies that might escape human analysis. And finally, international coordination through networks like the International Astronomical Union ensures that multiple independent teams analyze the same objects, reducing the risk of observational errors or biased interpretations that could lead to false conclusions about potential alien technology. Unanswered questions. What specific characteristics would definitively identify an object as alien technology rather than natural space debris? Scientists have established clear criteria for distinguishing artificial constructs from natural celestial objects, though, some borderline cases continue to challenge conventional analysis methods. Geometric precision in shape, surface features, or rotational periods would strongly suggest intelligent design, since natural processes rarely produce perfectly symmetrical or mathematically precise structures. Unusual material compositions containing pure metals, artificial alloys, or isotopic ratios inconsistent with stellar nucleosynthesis would indicate manufacturing rather than natural formation processes. Active electromagnetic emissions, especially coherent radio signals or structured data transmissions, would provide compelling evidence of technological origin and possibly intelligence. Propulsion signatures including unexplained acceleration, trajectory corrections, or energy emissions inconsistent with known natural forces would suggest artificial control systems. Surface features showing clear geometric patterns, construction joints, or manufacturing marks visible through high-resolution imaging would distinguish technology from natural geological processes. Internal structure revealed through radar or gravitational analysis might show artificial compartments, machinery, or organized systems, rather than homogeneous natural composition. Thermal anomalies indicating internal power sources, temperature regulation, or waste heat disposal would suggest active technological systems rather than passive solar heating. Response to external stimuli, such as changes in behavior when approached by spacecraft or exposed to radio signals, might indicate artificial intelligence or automated systems. The SETI Institute maintains protocols for evaluating potential techno-signatures, requiring multiple independent confirmations before announcing discoveries of artificial objects. Scientists continue refining detection methods and analysis techniques to ensure they can recognize genuine alien technology while, avoiding false positives from natural phenomena. The alien question. How do scientists balance open-minded investigation with rigorous skepticism when evaluating potential alien artifacts? The scientific method requires maintaining both receptivity to extraordinary discoveries and strict evidential standards that prevent premature conclusions about alien technology. Avi Loeb, chair of Harvard's astronomy department, advocates for seriously considering artificial origins when natural explanations prove inadequate, while emphasizing the need for extraordinary evidence to support extraordinary claims. Carl Sagan's famous principle that extraordinary claims require extraordinary evidence guides most astronomical investigations, ensuring that potential alien discoveries undergo the most rigorous peer review and verification processes. Scientists recognize that discovering genuine alien technology would represent one of humanity's most significant achievements, requiring absolute certainty to avoid false announcements that could damage scientific credibility. The SETI Institute has developed comprehensive protocols for evaluating potential techno-signatures, including multiple independent verification requirements and international coordination before making public announcements. Natural explanations must be thoroughly explored and eliminated before considering artificial origins, as the history of astronomy shows that apparently anomalous objects often have conventional explanations discovered through continued observation. Peer review processes ensure that multiple independent scientists analyze the same data and observations, reducing the risk of individual bias or analytical errors that might lead to incorrect conclusions. The scientific community maintains healthy skepticism while remaining genuinely open to discovering evidence of alien technology, balancing the need for rigorous investigation with the recognition that such discoveries would profoundly impact human understanding of our place in the universe and the prevalence of intelligent life throughout the galaxy. Dawn of a new era. What does the future hold for detecting and analyzing potentially artificial objects in our solar system? Technological advances in astronomy continue revolutionizing our ability to identify, track, and study mysterious visitors that might represent alien technology rather than natural space debris. Next-generation telescopes like the Vera Rubin Observatory will survey the entire visible sky nightly, dramatically increasing discovery rates for interstellar objects and providing rapid alerts for international follow-up observations. Advanced artificial intelligence systems will analyze observational data in real time, identifying subtle anomalies and patterns that might escape human attention, while flagging objects requiring immediate investigation. Space-based observation platforms will provide continuous monitoring capabilities without atmospheric interference, enabling detailed spectroscopic and thermal analysis of potentially artificial objects throughout their solar system passages. Improved international coordination through organizations like the International Astronomical Union ensures rapid information sharing and coordinated observation campaigns that maximize data collection from rare interstellar visitors. Radar astronomy facilities continue expanding their capabilities for detailed trajectory tracking and surface mapping, providing unprecedented precision in detecting artificial structures or unexpected motion patterns. Future space missions might include dedicated interceptor spacecraft designed to rendezvous with mysterious objects for close-range analysis, collecting samples and detailed measurements impossible from ground-based observations. The Breakthrough Listen project and similar initiatives continue expanding radio monitoring capabilities, searching for electromagnetic signatures that might indicate technological origins. Enhanced computer modeling and simulation capabilities will enable more sophisticated analysis of observational data, comparing observations with theoretical predictions for both natural and artificial objects to distinguish between conventional explanations and genuinely anomalous discoveries requiring extraordinary investigation. The search for alien technology requires balancing scientific rigor with open-minded investigation, ensuring we don't miss genuine discoveries while avoiding false alarms. As our detection capabilities advance, astronomers remain vigilant for objects that might represent humanity's first contact with extraterrestrial intelligence. Every mysterious visitor gets the same careful analysis, protecting both scientific credibility and our readiness for extraordinary discoveries. Keep exploring the cosmos with Simply Science, like, share and subscribe for more fascinating insights into our universe's greatest mysteries. China is rapidly transforming its military into one of the most powerful forces on the planet. Did you know that China now possesses over 600 nuclear warheads, nearly quadrupling its arsenal in just 5 years? This explosive growth isn't just about numbers, it's about reshaping global power. China's military strength is stronger than most people realize, but how much do you really know about the scale and sophistication of China's 2024 military capabilities? Nuclear arsenal growth. China's nuclear arsenal is expanding at a pace that has caught the world's attention, and for good reason. As of 2024, China possesses over 600 nuclear warheads, a dramatic increase of nearly 400 warheads since 2019. This rapid buildup is not just about numbers. It reflects a strategic shift aimed at challenging the long-standing nuclear dominance of the United States. What makes this growth even more significant is the construction of new missile silos across multiple regions, signaling that China is preparing to deploy a much larger and more diverse nuclear force than ever before. These silos could soon house a substantial portion of China's intercontinental ballistic missiles, giving the country a more credible and survivable nuclear deterrent. But China's nuclear strategy goes beyond sheer quantity. The People's Liberation Army is developing a wide range of nuclear weapons, from low-yield precision missiles designed for tactical use, to massive multi-megaton warheads capable of devastating strikes. This diversification allows China to tailor its nuclear response to different conflict scenarios, increasing its strategic flexibility. The pace and scale of this nuclear expansion highlight China's commitment to becoming a dominant global military power, capable of competing with the world's most advanced militaries. It's clear that China's nuclear force is no longer just a regional threat, it's a crucial element of global strategic balance that demands close attention. Understanding this growth is key to grasping the evolving nature of international security in 2024 and beyond. ICBM and silo deployment. China's rapid construction of new intercontinental ballistic missile silos is reshaping the global nuclear landscape in ways few expected. Over the past few years, satellite imagery and intelligence reports have revealed sprawling missile silo fields emerging across multiple provinces in China, signaling a massive expansion of its nuclear delivery infrastructure. Experts estimate that China could soon have over 300 silos, a dramatic increase from the handful it maintained just a few years ago. This development is not just about increasing numbers, it's about enhancing survivability and second strike capability. By dispersing its missiles across numerous hardened silos, China is making it far more difficult for any adversary to neutralize its nuclear forces in a first strike. This shift indicates a move away from a minimal deterrent posture, toward a more robust and credible nuclear force, capable of deterring even the most powerful opponents. The geographic spread of these silos also suggests strategic planning to cover multiple launch trajectories and complicate enemy targeting. Moreover, the silos are believed to be designed to house a new generation of advanced ICBMs with longer ranges and greater accuracy, further boosting China's strategic reach. This rapid and secretive buildup has caught the attention of global military analysts, raising questions about how the balance of nuclear power might shift in the coming decade. In short, China's missile silo expansion is a clear signal that its nuclear ambitions are growing far beyond what many had anticipated, making it a critical factor in global security calculations today. Diversification of nuclear forces. China's approach to its nuclear arsenal is evolving rapidly. And what stands out most is the diversification of its nuclear forces. Instead of relying on a one-size-fits-all strategy, China is developing a broad spectrum of nuclear weapons tailored for different scenarios. This means they're not just building massive, high-yield warheads designed for large-scale destruction, they're also investing in low-yield, precision-guided nuclear missiles that can be used more tactically. This diversification allows China to have more control over escalation during a conflict, giving them options that range from limited strikes to full-scale nuclear retaliation. It's a strategic move to make their nuclear deterrent more credible and flexible, which could complicate decision-making for any potential adversary. Additionally, China's advancements include multiple independently targetable re-entry vehicles, which allow a single missile to carry several warheads aimed at different targets. This technology multiplies the destructive potential of each missile and makes missile defense systems less effective. The combination of quantity, variety, and advanced technology signals that China is not just expanding its nuclear arsenal, but transforming it into a sophisticated and adaptable force. This shift is a clear message that China wants to be taken seriously as a global nuclear power, capable of defending its interests and deterring threats on multiple levels. The world is watching closely as this transformation unfolds, understanding that China's nuclear strategy in 2024 is far more nuanced and formidable than many anticipated. Theater command reforms. China's military has undergone a major transformation with its theater command reforms, fundamentally changing how its forces operate. Instead of a fragmented military structure, China now has 5 theater commands: Eastern, Southern, Western, Northern, and Central, each responsible for specific geographic regions and tailored to address unique security challenges. This reorganization boosts coordination and rapid response capabilities, allowing the People's Liberation Army to act more decisively in any conflict scenario. For example, the Eastern Theater Command focuses heavily on Taiwan and the East China Sea, while the Southern Command monitors the South China Sea, a hotspot for regional tensions. By assigning clear responsibilities and streamlining command chains, China has made its military far more agile and efficient. This shift also reflects China's broader strategic ambitions to project power regionally and beyond. The theater commands integrate land, sea, air, and missile forces under unified leadership, ensuring that all branches work seamlessly together during operations. This level of jointness is a significant leap forward compared to past decades when coordination was often limited. The reforms also emphasize modernization, with advanced technology and improved training playing a central role. What's striking is how these changes align with China's growing confidence on the world stage, signaling a military ready to defend its expanding interests. Understanding these theater commands is key to grasping how China plans to manage potential conflicts and assert its influence in Asia and beyond. It's a clear sign that China's military power in 2024 is not just about hardware, but about smarter, more integrated force projection. Naval power and power projection. China's naval ambitions have taken a giant leap forward, transforming the People's Liberation Army Navy from a coastal defense force into a formidable blue water navy capable of projecting power far beyond its shores. Over the past decade, China has launched multiple advanced aircraft carriers, modern destroyers, and amphibious assault ships, signaling its intent to operate globally and challenge established naval powers. This expansion allows China to safeguard its growing overseas interests, including vital trade routes and strategic bases. The plan's increasing presence in the Indo-Pacific region is reshaping the balance of power, especially as it challenges the United States Navy's long-held dominance. What's remarkable is not just the size of the fleet but the sophistication of its vessels, many equipped with cutting-edge missile systems, stealth technology, and advanced radar. This modernization enhances China's ability to conduct complex operations, from anti-submarine warfare to missile strikes at sea. The Navy's growing capabilities also support China's broader strategic goals, such as asserting territorial claims in contested waters like the South China Sea and expanding influence in the Indian Ocean. These developments have prompted neighboring countries and global powers to rethink their naval strategies, underscoring how China's maritime rise is a game-changer. In 2024, the plan stands as a symbol of China's determination to become a dominant maritime force, capable of defending its interests and shaping the future of global naval power. This shift is more than just military growth, it's a statement about China's place on the world stage. nuclear submarine advancements. China's underwater nuclear deterrent is quietly becoming one of the most powerful and stealthy forces in the world. Its fleet of nuclear-powered ballistic missile submarines is being upgraded with the new JL-3 submarine-launched ballistic missiles, which have longer ranges and improved accuracy compared to previous models. This upgrade significantly enhances China's second strike capability, the ability to retaliate even after a devastating first strike, making its nuclear deterrent far more credible and survivable. Unlike land-based missiles, these submarines can operate undetected in vast ocean areas, making them extremely difficult to track or target. This stealth factor gives China a strategic advantage by ensuring that any potential adversary must think twice before considering a nuclear attack. The expansion and modernization of China's SSBN fleet also reflect a broader shift in its military strategy towards securing its nuclear forces in multiple domains. By investing heavily in underwater nuclear capabilities, China is signaling that it intends to maintain a robust and flexible deterrent that can operate independently of land-based systems. This development is crucial because it adds a new layer of complexity to global nuclear stability and deterrence dynamics. As China continues to improve its submarine technology and missile range, its underwater nuclear force will play an increasingly vital role in shaping the balance of power, especially in the Indo-Pacific region. This silent but powerful presence beneath the waves is a key piece of China's growing military strength in 2024. Space and counter-space capabilities. China's ambitions in space warfare are rapidly advancing, turning the final frontier into a new battleground. In 2024, China is investing heavily in counter-space capabilities designed to neutralize or destroy adversaries' satellite systems, which are critical for communication, navigation, and intelligence. This includes a range of anti-satellite weapons, from ground-based missiles to directed energy weapons, all aimed at disrupting the space assets of potential rivals. Controlling space is no longer just about exploration, it's about gaining a decisive military edge. Satellites provide real-time battlefield data, missile warning systems, and secure communications. Without them, modern militaries would be severely handicapped. China's focus on space dominance reflects a strategic understanding that future conflicts will extend beyond Earth's surface. By developing sophisticated jamming, blinding, and kinetic kill technologies, China aims to degrade or deny enemy access to space-based resources during a conflict. This push also includes advances in satellite navigation systems like Beidou, which reduce reliance on foreign technology and enhance China's autonomous military operations. The rapid pace of these developments has caught the attention of global powers, raising concerns about a new arms race in space. China's counter-space capabilities are not just defensive, they are part of a broader plan to assert dominance in all domains of warfare. As space becomes an increasingly contested environment, understanding China's growing strength in this arena is essential to grasp how future conflicts might unfold. Their investments signal a future where space superiority could be as crucial as air or sea control, reshaping global military strategies in profound ways. Integration of advanced technologies. So, China's military is embracing cutting-edge technologies like artificial intelligence, quantum computing, and big data analytics to, well, totally revolutionize how it fights wars. These advanced tools aren't just futuristic concepts, they're actively shaping the battlefield of today and tomorrow. Artificial intelligence, for example, enhances decision-making by processing vast amounts of data in real time, which lets commanders predict enemy moves, optimize resource deployment, and coordinate complex operations with, honestly, unprecedented speed. Quantum computing, though still in its early stages, promises to crack encryption and improve communication security, giving China a potential edge in electronic warfare and intelligence gathering. Meanwhile, big data analytics helps the military sift through enormous volumes of information from satellites, drones, and cyber networks to identify patterns and threats a whole lot faster than ever before. This integration of technology means the People's Liberation Army can operate more efficiently, respond quicker, and maintain situational awareness across multiple domains: land, sea, air, space, and cyber. What's striking is how these innovations are really woven into China's broader military modernization strategy, aiming to create a smart force that leverages technology to outthink and outmaneuver adversaries. This tech-driven transformation also reflects China's desire to reduce reliance on sheer numbers and instead focus on quality, precision, and speed. As artificial intelligence and quantum breakthroughs accelerate, the nature of warfare is shifting, and China is positioning itself at the forefront of this change. Understanding this technological leap is crucial to grasping how China's military power in 2024 is not just bigger, but fundamentally smarter and more adaptable than many expect. Missile forces and regional deterrence. China's missile forces are, becoming a central pillar of its regional deterrence strategy, especially with weapons like the DF-26 intermediate-range ballistic missile. Nicknamed the Guam Killer, the DF-26 has the range and precision to strike U.S. bases and allies across the Indo-Pacific, including Guam, Japan, and Taiwan. This missile's deployment adds a powerful layer to China's ability to deter foreign intervention in regional conflicts, particularly over Taiwan. What makes the DF-26 especially concerning is its versatility. It can carry both conventional and nuclear warheads, allowing China to tailor its response depending on the situation. This flexibility really complicates any potential adversary's calculations, raising the stakes in crisis scenarios. Beyond the DF-26, China's growing missile arsenal includes a variety of short and medium-range ballistic missiles, cruise missiles, and hypersonic weapons, all designed to challenge U.S. and allied forces operating near China's borders. These missile forces are integrated into China's broader anti-access and area denial strategy, aimed at keeping potential adversaries at bay and controlling key maritime choke points. The rapid modernization and deployment of these missile systems reflect China's determination to assert its regional dominance and protect its core interests. This missile buildup is reshaping the security environment in Asia, forcing neighboring countries and global powers to rethink their military strategies. In 2024, China's missile forces are not just a threat on paper. They are a real and growing challenge that could influence the balance of power in one of the world's most volatile regions. Future growth and strategic ambitions. China's military modernization isn't slowing down anytime soon. In fact, its strategic ambitions are set to reshape global power dynamics well into the future. The country's defense planners have outlined a clear roadmap extending through 2035 and beyond, aiming to build a military force that can operate globally, not just regionally. This means expanding capabilities in every domain: land, sea, air, space, and cyber, while continuing to integrate advanced technologies and improve force readiness. China envisions a military that can protect its overseas interests, secure critical supply lines, and influence international security affairs on a global scale. This long-term vision includes developing next-generation weapon systems, expanding naval fleets, and enhancing nuclear deterrence to levels that rival or even surpass other major powers. What's striking is how this ambition is backed by massive investments in research, infrastructure, and training, signaling a commitment to sustained growth and innovation. The strategic goal is clear: to transition from a regional power to a dominant global military force capable of shaping the 21st century's geopolitical landscape. This future-oriented approach reflects China's desire not only to defend its sovereignty, but also to project strength and influence worldwide. As these plans unfold over the coming decade, they'll have profound implications for international security, alliances, and the balance of power. Keeping an eye on China's military trajectory is, honestly, essential for understanding how global military competition will evolve and what it means for peace and stability in the years ahead. Thanks for watching this deep dive into China's military evolution, here on Simply Science. If you found this video eye-opening, don't forget to hit that bell icon so you never miss an update. Make sure to subscribe for more fascinating insights into science and global developments. We'd love to hear your thoughts. Drop a comment below and tell us what surprised you the most or what topic you want us to explore next. Your engagement really helps us create better content for you. See you in the next video. It started as nothing more than a flicker, barely a whisper in the data streams flowing from observatories around the world. But when James Webb Space Telescope captured its first detailed image of the mysterious interstellar visitor 3Y Atlas, scientists realized they were witnessing something that could rewrite our understanding of the cosmos. This ancient traveler from beyond our solar system carries secrets that challenge everything we thought we knew about space. The flicker in the dark. The discovery of 3Y Atlas started, not with a bang, but with a faint cosmic flicker detected by the Atlas telescope at Rio Hurtado, Chile in early July 2025. Astrophysicist Matthew Payne at the Minor Planet Center was among the first to flag its interstellar trajectory, confirming that what began as a whisper in Atlas survey data was unlike anything bound to our sun. Days later, a global alert went out to observatories worldwide, and research teams coordinated with NASA's JWS team to track this mysterious visitor. This collective effort led to the crucial moment when NASA released its first image, ultra-detailed and definitive, immediately captivating Dr. Payne's team and the world's top interstellar object researchers. The initial detection required sophisticated computer algorithms to distinguish the object's movement against the crowded stellar background near the constellation Sagittarius. Multiple observatories confirmed the unusual motion patterns within 48 hours, establishing international protocols for rapid follow-up observations. The discovery highlighted how advanced survey systems have revolutionized our ability to detect cosmic visitors that would have remained invisible just decades ago. Beyond the solar veil. Pinpointing the origin, the Atlas team led by Larry Deneau confirmed 3Y Atlas's interstellar status, distinguishing it by its hyperbolic excess velocity well above the escape velocity from the Sun. Analysis by Dr. Karen Meach, who also characterized Oumuamua, showed the orbital data marked its point of entry far above the ecliptic, entering from deep space. Observatories from the European Southern Observatory to Mauna Kea, Hawaii, contributed positional data that painted a picture of an object traveling for potentially millions of years through interstellar space. These collaborative efforts proved this was the third object after Oumuamua and Borisov to have entered from outside the solar system, sparking a fast-tracked global campaign to track and analyze it before it disappeared forever. The object's trajectory suggested it had been wandering the galaxy for eons, carrying pristine materials from its unknown stellar birthplace. International astronomers worked around the clock to maximize observation time, knowing that such visitors offer rare glimpses into the composition and conditions of distant star systems. The coordinated response demonstrated how the astronomical community has learned from previous missed opportunities with earlier interstellar visitors. The accelerating mystery. Why does 3I Atlas exhibit velocity patterns that fundamentally challenge our understanding of celestial mechanics? Scientists conducting comprehensive trajectory analysis have discovered that this enigmatic interstellar visitor displays acceleration characteristics completely unlike typical comets or asteroids native to our solar system. While most celestial objects follow precisely predictable orbital paths determined exclusively by gravitational influences from the Sun and planets, 3I Atlas demonstrates subtle yet scientifically significant deviations from all expected trajectories based on conventional physics models. These anomalous acceleration patterns strongly suggest that forces extending far beyond simple gravitational attraction are actively influencing its motion through space in ways that current astrophysics cannot fully explain. The object's peculiar behavior bears striking resemblance to that of one Oumuamua, which famously displayed mysterious non-gravitational acceleration that completely baffled the global scientific community and sparked intensely controversial theories about possible artificial origins. Early observational data revealed 3I Atlas beginning active cometary outgassing while still positioned 4.5 astronomical units from the Sun, a distance much greater than where typical solar system comets begin their characteristic, volatile sublimation processes. This remarkably early activation, combined with its highly unusual velocity profile and trajectory characteristics, creates an accelerating scientific mystery that fundamentally challenges conventional theoretical models of cometary physics and interstellar object behavior. The extraordinary combination of extreme hyperbolic velocity, unprecedented trajectory parameters, and completely anomalous acceleration signatures has forced astronomers worldwide to seriously reconsider fundamental assumptions about how interstellar objects behave when passing through alien star systems, opening entirely new avenues of research into the complex dynamics governing these mysterious cosmic wanderers. Patterns in the void. The intrigue deepened when the Vera C. Rubin Observatory Analysis Group, led by Dr. Zdenka Vokrulicki, noted a trend in the frequency of interstellar objects visiting our solar system. Since the surprise of Oumuamua in October 2017 and 2I/Borisov in December 2019, detection rates have steadily increased, thanks to improved survey technology and, better international coordination. The International Astronomical Union actually convened a special panel to discuss the implications for galactic object exchange, stressing that the regular arrival of such bodies really challenges previous models of solar system isolation. Each confirmed object, now that's 3 in under a decade, forces a rewriting of our assumptions about material drifting between stars and the dynamic nature of our galactic neighborhood. Statistical analysis suggests that thousands of similar objects pass through the outer solar system undetected each year, representing a vast population of interstellar wanderers. The pattern indicates that our solar system sits within a stream of cosmic debris ejected from stellar systems throughout the Milky Way galaxy. And advanced detection capabilities promise to reveal many more such visitors, fundamentally changing our understanding of how matter moves between star systems and the frequency of interstellar exchanges. The machine hypothesis. New web imagery processed by the Space Telescope Science Institute in Baltimore and interpreted by a multidisciplinary panel led in part by Dr. Avi Loeb, set off debate on possible artificial origins. Loeb highlighted unexpected geometry in the object right-angle reflectivity patterns and non-random surface features that seemed inconsistent with natural formation processes. The European Space Agency's JWST spectroscopy division found thermally anomalous regions and odd shadowing that defied conventional models of cometary behavior. Team member Dr. Heidi Hamel, planetary scientist and JWST co-investigator, cautioned that such findings don't yet confirm technology, but the conversation around the machine hypothesis went global after unexpected press releases. The object's surface appeared remarkably smooth and uniform, lacking the irregular features typical of natural space debris that's been battered by cosmic rays and micrometeorites during interstellar travel. Advanced imaging revealed geometric patterns that some researchers interpreted as possible structural elements, though others argued these could result from unusual crystallization processes during the object's formation. The debate really highlighted the challenges of distinguishing between natural and artificial characteristics when examining objects from unknown stellar environments with, well, potentially different formation conditions. Spectral secrets. Spectroscopic data from the James Webb NIRSpec instrument showed 3I/Atlas contains unfamiliar mixtures of organics, silicates, and metallic alloys, not typical for solar system comets. Dr. Alan Fitzsimmons from Queen's University Belfast identified a significant absorption at 1.5 microns, associated with hydrated minerals, alongside anomalous emission lines unexplained by water or carbon dioxide alone. NASA's Goddard Space Flight Center provided confirmation, reporting faint but consistent microwave emissions that suggested active internal processes. Dr. Jessica Agarwal from the German Aerospace Center noted these combined features could suggest prior irradiation or artificial alteration of native ices, fueling both natural and technological hypotheses about the object's origin. The spectral signatures revealed isotopic ratios that differed from typical solar system materials, indicating formation in an environment with different stellar nucleosynthesis products. Rare Earth elements appeared in concentrations that challenged existing models of planetary formation and cometary composition. And the presence of complex organic molecules typically associated with biological processes sparked additional speculation, though researchers emphasized that such compounds can form through natural chemical processes in interstellar space. The information blackout. So, amid mounting discoveries, global scientists started to notice restricted access to JWST raw data beginning on August 18, 2025. Dr. Joseph Maciero of the Planetary Defense Coordination Office testified that agency data review protocols were now being applied to 3I/Atlas, and well, he cited national security as the reason for limiting information sharing. Meanwhile, SETI Institute researchers, led by Dr. Jill Tarter, raised open letters demanding transparency, and the European Space Agency's Gaia mission team quietly shared independent astrometry with their international colleagues. Tensions really flared during an American Astronomical Society session, when international collaboration took a back seat to agency security reviews. This just revealed the growing friction between open science and government oversight on cosmic anomalies. Scientists expressed a lot of frustration that crucial observation windows were being compromised by bureaucratic delays and, honestly, classification concerns. The controversy really highlighted some fundamental questions about who controls access to cosmic discoveries and whether potential extraterrestrial contact should be subject to governmental secrecy. In response, international researchers began developing independent observation networks to ensure that scientific data would remain accessible to the global community, regardless of individual government policies regarding space-based discoveries and their potential implications for national security. Controlled heat and hidden intent. Thermal mapping using Webb MIRI instruments, supervised by Dr. Michael Werner at JPL, exhibited these adaptive temperature zones across the object's surface, which honestly is not something you see in typical comets. Dr. Christina Thomas at Northern Arizona University presented findings of synchronous heat regulation, and that really stands out, especially when you compare it to the chaotic surface cooling we've seen on icy nuclei, like 67P Churyumov-Gerasimenko. Now, key data obtained near perihelion on August 19, 2025, revealed the stabilization of energy emission regions that actually seem to respond intelligently to solar heating. Theorist Dr. Gregory Laughlin at Yale even hypothesized that such signatures might imply, quote, thermal shielding or technology for intent-driven adaptation, a radical but now openly discussed possibility among planetary scientists. The temperature control followed these predictable patterns that maintained optimal conditions for preserving internal structures, and that honestly suggests either remarkable natural adaptation or deliberate engineering. Computer models showed that natural processes alone just couldn't account for the precision of thermal regulation observed across different surface regions. What's even more surprising is that the controlled heating patterns persisted, even as the object moved through varying solar radiation intensities, indicating active, rather than passive, thermal management systems that really defy our conventional understanding of cometary physics. The prime number message. Analysis teams at the Max Planck Institute for Radio Astronomy, led by Dr. Michael Kramer, detected heat emission modulations that, after Fourier transformation, revealed repeated prime number sequences embedded in the thermal output. Dr. Sophia Sheikh, a SETI researcher, independently validated a 17-23-31 pattern in night-to-night thermal variations using Green Bank Observatory data and, well, some pretty sophisticated signal processing techniques. This prime encoding is considered by scientists, as originally argued by Carl Sagan, to be the most likely signal structure used by non-human intelligences trying to communicate across interstellar distances. The findings, if verified by international SETI groups, could actually represent the first candidate evidence for information intentionally encoded in a celestial object passing through our solar system. The mathematical sequences appeared with statistical significance far exceeding random thermal fluctuations, suggesting deliberate modulation of heat emission patterns. Multiple independent verification attempts confirmed those prime number sequences across different observation periods and wavelengths. The discovery prompted emergency sessions at SETI institutes worldwide, as researchers grappled with the possibility that, just maybe, humanity had detected its first confirmed extraterrestrial communication attempt, though, of course, skeptics continued to search for natural explanations. The Watchers and the Watched. With the International Astronomical Union's special session, the world watched as experts like Dr. Lisa Kaltenegger from Cornell, astrobiologist Dr. Sarah Seeger, Planetary Protection Officer Dr. Catherine Conley, and SETI pioneer Frank Drake reflected on the profound implications of these discoveries. The paradigm has fundamentally shifted. The idea that humanity is the primary watcher of the cosmos has, well, inverted, with 3-eye atlas representing potential evidence that we ourselves are being observed and studied. This reversal sparks some really intense debate about whether ethical and existential responsibilities should ever be confirmed, especially with direct, possibly intentional signatures detected in a passing interstellar visitor. The story of 3-eye atlas will shape cosmic policy, philosophy, and planetary science for decades to come as humanity grapples with its changing role in the universe. Scientists are now developing new protocols for handling potential extraterrestrial contact scenarios, recognizing that traditional assumptions about human cosmic isolation may no longer apply. The discovery has prompted philosophical discussions about humanity's readiness for contact with advanced civilizations and the implications of being observed by intelligence that may have been studying Earth for extended periods. International cooperation frameworks are being established to ensure unified responses to future encounters with potentially artificial interstellar objects. The first real image from the James Webb Space Telescope begins a bold chapter in cosmic history. As data pours in and global teams compete and cooperate across boundaries, 3I Atlas stands as both a scientific puzzle and a reminder of our shared curiosity about the universe. The search for answers continues to accelerate with each new discovery. Keep exploring the cosmos with Simply Science. Like, share, and subscribe for our next cosmic revelation. Jupiter isn't just the largest planet in our solar system. It's a cosmic monster hiding secrets that could rewrite physics textbooks. While we've admired its colorful bands for centuries, NASA's Juno spacecraft discovered something absolutely terrifying. Perfectly organized storm systems that shouldn't exist, mysterious ammonia towers stretching thousands of kilometers high, and a great red spot that's dying faster than scientists ever predicted. But here's the kicker. Jupiter might be more alien than we ever imagined. Did you know Jupiter's magnetic field is so chaotic it would instantly kill any human who got too close? The mystery storm discovery. Scientists expected chaos when Juno peered into Jupiter's depths, but what they found was far more unsettling. Perfect order where none should exist. Hidden beneath the planet's familiar bands are storm systems arranged in geometric patterns so precise they look engineered. These aren't random weather events, they're mega-cyclones that have been spinning in formation for potentially millions of years. Dr. Alberto Adriani, from the Institute for Space Astrophysics in Rome, describes them as impossible structures that violate everything we know about fluid dynamics. The storms maintain perfect spacing, like gears in a planetary machine, each one larger than Earth and more powerful than anything in our solar system. What's keeping them organized? Why haven't they merged or dissipated like normal storms should? Juno's data suggests these formations extend thousands of kilometers deep, powered by energy sources that remain completely unknown. The geometric precision is so unnatural that some researchers privately wonder if they're witnessing the remnants of some ancient cosmic event that fundamentally altered Jupiter's atmospheric behavior. Each storm rotates with mathematical precision, creating a pattern that defies the chaotic nature of fluid mechanics. Steeple Mountain discovery. Deep beneath Jupiter's swirling surface, Juno's microwave radiometer detected something that shouldn't exist: towering structures of ammonia rising like ghostly skyscrapers through the dense atmosphere. These steeple mountains stretch 3,000 kilometers high, making Earth's tallest peaks look like pebbles. But here's the terrifying part. They're not solid. These are fluid towers, streams of superheated ammonia shooting upward at velocities that would tear apart any earthly structure. Dr. Scott Bolton and his team at NASA's Jet Propulsion Laboratory initially thought their instruments were malfunctioning. How could liquid structures maintain such height in an environment where pressure should crush everything? The discovery suggests Jupiter's interior is far more turbulent than anyone imagined, with convection currents powerful enough to launch material thousands of kilometers upward. These aren't isolated events. Juno has detected dozens of these formations, some persisting for months, while others appear and vanish like cosmic mirages. The ammonia plumes carry with them traces of deeper materials, offering glimpses into Jupiter's mysterious core regions where temperatures exceed 20,000 degrees Celsius. What force is driving these massive eruptions from Jupiter's depths? Largest eruption recording. On March 15, 2021, Juno witnessed Jupiter unleash its fury in ways that left scientists speechless. What started as routine atmospheric monitoring became documentation of the most violent planetary eruption ever recorded. Material exploded from Jupiter's depths at 150 meters per second, creating a shockwave that rippled across the entire hemisphere. This wasn't just a storm, it was a planetary convulsion that ejected enough material to bury Texas under 10 meters of debris. The eruption originated from pressures 100 times greater than Earth's surface, in regions where the atmosphere becomes so dense it behaves more like liquid metal than gas. Juno's instruments recorded temperature spikes exceeding 2,000 degrees Celsius, as the explosion tore through atmospheric layers that had remained stable for centuries. The sheer violence of the event suggests something catastrophic occurred in Jupiter's deep interior. Perhaps the collapse of a massive atmospheric structure, or the release of energy that had been building for decades. What's most disturbing is that this might not be rare. Analysis of Juno's 4-year dataset reveals smaller versions of these eruptions occurring regularly, like a planet-sized pressure cooker releasing steam. Each eruption carries chemical signatures from depths no spacecraft has ever sampled, offering terrifying glimpses into the hellish conditions that exist within our solar system's largest world. Jupiter's magnetic field. Forget everything you thought you knew about planetary magnetic fields. Juno's magnetometer revealed that Jupiter's magnetic environment is a chaotic nightmare that would instantly kill any unprotected visitor. Instead of the simple, predictable dipole field scientists expected, Jupiter possesses a twisted, lumpy magnetic field that defies all theoretical models. In some regions, the field's strength reaches 20 times Earth's intensity, while in others it nearly vanishes completely. Dr. Kimberly Moore at Harvard University describes it as magnetic chaos on a planetary scale. The field's bizarre structure suggests Jupiter's core isn't the solid, well-organized sphere scientists assumed. Instead, it appears partially dissolved, creating a churning metallic hydrogen dynamo that generates magnetic mayhem. This chaos extends millions of kilometers into space, creating radiation belts so intense they would cook electronics instantly and deliver lethal doses to humans in seconds. Juno itself barely survives each close approach, with its instruments shutting down to prevent damage from the crushing radiation. The magnetic field's unpredictable nature also means Jupiter's moons experience wildly varying radiation exposure as they orbit. Europa and Io are constantly bombarded by charged particles accelerated to near-light speeds, creating auroras visible from Earth but also sterilizing their surfaces with deadly efficiency. Atmospheric water mystery. Here's where Jupiter's story takes a sinister turn. Juno's near-infrared spectrometer was designed to map Jupiter's water content, but instead it discovered something far more unsettling: massive regions where water mysteriously vanishes. According to planetary formation theory, Jupiter should be rich in water vapor, yet Juno found vast dry zones where H2O readings dropped to nearly zero. Dr. Chung Lee at the University of California, Berkeley calls it the missing water problem, but the implications are far more disturbing than the name suggests. Something is actively consuming or hiding Jupiter's water and scientists have no idea what. The dry zones aren't random. They appear in organized patterns that correlate with the planet's mysterious deep storm systems. In some regions, water abundance fluctuates wildly over timescales of hours, as if something is feeding on it in massive gulps. Chemical analysis reveals traces of exotic compounds that shouldn't exist in Jupiter's supposed water-rich environment. These mysterious substances appear wherever water disappears, suggesting some unknown chemical process is converting H2O into unidentifiable products. The water mystery gets worse the deeper Juno looks. Pressure levels where liquid water should be abundant show the most extreme depletion, hinting that whatever is consuming Jupiter's water prefers the high-pressure environments deep within the planet. Polar cyclone dynamic. Jupiter's poles revealed a site so perfectly organized it seems almost artificial. Geometric arrangements of cyclones that have maintained their formation for over 8 years since Juno's arrival. The North Pole hosts 8 cyclones arranged in a perfect octagon around a central storm, while the South Pole displays 5 cyclones in a pentagon formation. Each of these storms is larger than Earth, spinning at velocities exceeding 350 kilometers per hour, yet they never merge or drift from their positions. Dr. Alberto Adriani from Italy's National Institute for Astrophysics describes the formation as geometrically impossible according to known atmospheric physics. The cyclones maintain precise spacing like dancers in a cosmic ballet, each one feeding off the others in ways that shouldn't create stability. What's most unnerving is their persistence. These storms have shown no signs of weakening or changing position despite the chaotic nature of Jupiter's atmosphere. Computer simulations attempting to recreate these formations consistently fail, suggesting fundamental gaps in our understanding of atmospheric dynamics. The cyclones rotate in alternating directions, creating a complex system of vortex interactions that generates its own weather patterns. Deep within each storm, Juno detected temperature anomalies and chemical signatures that differ from the surrounding atmosphere, as if each cyclone is connected to different regions of Jupiter's interior through unknown mechanisms. Jupiter's composition and structure. Juno shattered every textbook description of Jupiter's interior structure, revealing a planet that assembled itself using rules we don't understand. Instead of the neat, layered structure scientists expected, Jupiter possesses a fuzzy core that extends halfway to the surface, a discovery that invalidates 50 years of planetary formation theory. Heavy elements like silicon and iron, which should have settled into a compact central core, are instead mixed throughout the planet in impossible concentrations. Dr. Tristan Guillot from the Côte d'Azur Observatory describes Jupiter's interior as dilute core soup, a churning mixture where rock, ice, and metallic hydrogen swirl together in ways that violate basic principles of planetary differentiation. The implications are staggering. If Jupiter formed differently than we thought, then our entire understanding of solar system evolution is wrong. Gravitational measurements reveal density variations that shouldn't exist, suggesting Jupiter's interior is constantly reshuffling itself through unknown mechanisms. Temperature gradients detected by Juno indicate heat sources distributed throughout the planet rather than concentrated at the core, challenging fundamental assumptions about how giant planets generate energy. The fuzzy core discovery also explains why Jupiter radiates 2.5 times more energy than it receives from the Sun. It's essentially a failed star still contracting and generating heat through gravitational compression, but in ways far more complex than scientists ever imagined. Great Red Spot Analysis. The Great Red Spot isn't just Jupiter's most famous feature, it's a window into the planet's terrifying depths. Juno's close-up analysis revealed this iconic storm extends 300 kilometers deep, with routes that may connect directly to Jupiter's core regions. But the most disturbing discovery wasn't its depth, it was what's keeping it alive. The spot's distinctive orange-red color comes from complex organic compounds that shouldn't exist at those atmospheric pressures and temperatures. Dr. Amy Simon at NASA's Goddard Space Flight Center describes these chemicals as atmospheric ghosts, substances that appear and disappear in ways that violate known chemistry. The storm isn't just spinning randomly, it pulses with a rhythm like a planetary heartbeat, expanding and contracting in 87-day cycles that seem connected to Jupiter's rotation period. Juno's data reveals the Great Red Spot is actually hollow at its center, creating a massive atmospheric vortex that acts like a planetary drain. Material gets sucked into this central void and disappears into Jupiter's depths, carrying surface chemicals into regions where they undergo unknown transformations. Most unsettling of all, the storm shows signs of intelligence. Its behavior changes in response to external stimuli, almost as if it's aware of Juno's presence. The Great Red Spot has survived for over 400 years by feeding on smaller storms, absorbing their energy and growing stronger, like an atmospheric predator that dominates Jupiter's weather systems. Jupiter as planetary protector. While Jupiter protects Earth from cosmic debris, Juno revealed this protection comes at a horrifying cost to anything that ventures too close. The planet doesn't just deflect asteroids and comets, it captures them in gravitational death spirals that tear objects apart atom by atom before consuming their remains. Juno's atmospheric analysis detected the chemical signatures of countless destroyed worlds, including metallic traces that suggest entire moonlets have been devoured over millions of years. Dr. Heidi Hamel from the Association of Universities for Research in Astronomy calls Jupiter a cosmic meat grinder that processes solar system debris with terrifying efficiency. The planet's tidal forces are so intense they can shred objects hundreds of kilometers across, turning solid bodies into streams of molten rock and metal. Juno witnessed several small asteroids meet this fate, documenting their final moments as they spiraled into Jupiter's crushing embrace. The gravity well extends far beyond Jupiter itself. Objects passing within 2.5 million kilometers begin experiencing tidal stress that eventually proves fatal. What's most disturbing is the sheer scale of destruction. Juno's chemical analysis suggests Jupiter has consumed thousands of large objects throughout its history, including bodies that might have supported primitive life. Each impact adds to Jupiter's mass and energy, making it an ever-growing cosmic vacuum cleaner that grows more powerful with each meal. The planet's protective role comes with an appetite that never stops growing. Great Red Spot Shrinking. The most iconic feature in our solar system is dying, and its death throes might be more catastrophic than anyone imagined. Juno's precise measurements confirmed the Great Red Spot is shrinking at an accelerating rate, having lost over 50% of its size since the 1800s. At current rates, this 400-year-old storm system could vanish completely within 20 years. But here's the terrifying part. As it shrinks, It's becoming more intense, like a cosmic pressure cooker building toward an explosive finale. Wind speeds within the shrinking storm have increased to over 650 kilometers per hour, creating conditions more violent than anything previously recorded on Jupiter. Dr. Glenn Orton at NASA's Jet Propulsion Laboratory warns that the spot's collapse could trigger massive atmospheric upheavals across Jupiter's entire hemisphere. The shrinking process appears irreversible, driven by changes in Jupiter's deep circulation patterns that Juno is still struggling to understand. As the Great Red Spot contracts, it's pulling material from deeper atmospheric layers, concentrating energy and chemical compounds in ways that could destabilize surrounding weather systems. Computer models attempting to predict the spot's final collapse consistently crash, unable to process the extreme conditions created by the dying storm. What happens when 4 centuries of accumulated atmospheric energy gets released all at once? Juno might be positioned to witness the most violent planetary weather event in recorded history, the death of a storm so massive it has shaped Jupiter's appearance for longer than humans have been studying the planet. So there you have it, Jupiter's most terrifying secrets revealed by Juno's groundbreaking mission. From impossible storm formations to the dying Great Red Spot, our solar system's giant is far more mysterious and dangerous than we ever imagined. These discoveries are just the beginning of what Simply Science brings you every week. If these cosmic revelations blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. What shocked you most about Jupiter's hidden mysteries? Drop your thoughts in the comments below. I read every single one. Until next time, keep questioning the universe.